Today's lesson we are going to start the study of trigonometry, which trigonometry is the study of triangles. We've studied triangles before. In geometry, we've studied sine, cosine, and tangent. So basically, that's what we're going to start looking at is studying triangles. Today, we're going to start with the basics. So we're going to learn some key things that are going to be very important throughout the rest of the semester. So first off, we're going to start with some definitions. So the first definition that you're going to hear a lot is called a unit circle. What a unit circle is, it's a circle with a radius of 1. It could be 1 mile, it could be 1 inch, it could be 1 centimeter, it could be lots of different things, 1 foot, but it's just 1, okay? Now, the next one, and most of you may have heard of the word radian, but a lot of students aren't familiar with radians. What a radian is it's the distance around the unit circle. So essentially it's the circumference. So the circumference around the unit circle is going to be 6 pi because it's 2 pi r. Circumference is 2 pi r. So the radius is 1. So it's 2 times pi times the radius, which is 1. Okay. So that's what a radian is. It's the distance around the unit circle. Essentially, it's the circumference around the circle. All right. Today, we're going to talk about Pythagorean theorem, which you should remember from lots of classes previously. A squared plus b squared equals c squared. Another one we're going to talk about is Pythagorean triples, our numbers that work in the Pythagorean theorem. The most common is 3, 4, 5. You'll also get 6, 8, 10. Another one is 5, 12, 13. Those are the ones you'll see a lot in this class. Make sure I would memorize those. 3, 4, 5, 6, 8, 10, 5, 12, 13. Those will also be very common ones when you take the ACT test. If you know those, it makes calculations a lot quicker. Okay. One of the things we're going to do today is we're going to convert from radians to degrees and from degrees to radians. And it's a really basic conversion using a line conversion. And it's 180 divided by pi. So if I'm going to convert from radians to degrees, we convert by using 180 divided by pi. In order to convert from degrees to radians, we use pi divided by 180. Okay, and so we'll talk about how to use those conversions in a little bit. Little geometry review. There are two special right triangles, 45, 45, 90 triangle and a 30, 60, 90 triangle. You need to memorize these as soon as you can. Okay. Some people teach it as x squared root of 2, and then x squared root of 3 and 2x. Others teach it where they put in 1, and then just the square root of 2, and then 1 square root of 3 and 2. They serve the same purpose. Essentially, what you do is you use similar triangles from geometry. You set up proportions and you figure out what they are. If you need to. So let's look at some basic examples. All right. So convert radians to degrees and degrees to radians. Okay. So right here we have a degree measurement. Okay. So I want to convert this to a radian measurement. So what I do is I use a line conversion, which means I'm going to use multiplication. And a line conversion means I'm going to work on getting rid of the unit of measurement called degrees, because that's what I'm in. So what I do is I make a fraction over here. I have that conversion from the previous page. It's either 180 divided by pi or pi divided by 180. And the way that I remember this is I have degrees here. I have a fraction here. I'm doing multiplication. So in order to get degrees to cancel out, I put the degree measurement in the denominator, because what that's going to do is it's going to cancel your unit of measurement. Well, degrees is 180 degrees. Pi is the radian measurement that's equivalent to 180 degrees, and I'll explain that here in just a second. So what do? I now multiply. 30 times pi is going to be 30 pi over 180 degrees. Then what you do is you simplify 30 and 180. Well, since both of them end in zeros, that means I can cross the zeros out. Then I have 3 and 18. Well, both of these have a factor of 3. Get rid of the 3's, and I get pi over 6. And that is the radian measurement. You'll become very familiar with pi over 6. Okay? Now, kind of go back to why we use pi and 180. Okay, if you think about a circle, here's a circle, and I have a center here. Let's call this the radius. If I rotate 180 degrees, 180 degrees is a straight line. Okay, so this right here would be 180 degrees. Okay, straight line. What I'm doing is the radian measurement is the distance around the outside of the circle. So if I was to rotate from here all the way around to here, how much of the circle is that? It's half the circle. Well, the circumference of a circle is 2 pi r. The radius of this is 1 because it's a unit circle. So this would become 2 pi times 1, which is just 2 pi. That's all the way around. I only want half of that. Now divide that by 2, and you get pi. So essentially what that's saying is 180 degrees and pi are the same angle measurement. It's like saying 12 feet or 12 inches is 1 foot. They're the same distance, just in different units of measurement. 30 degrees and pi over 6 are talking about the same angle measurement, just in different units of measurement. Okay, so let's go down here and do 200. Okay, so I'm going to drop down here. So I'm going to multiply by a fraction, and again, I want to get rid of degrees, so I put degree measurement in the bottom. Well, 180 degrees is equivalent to pi radians. So what do? I reduce. I get 200 pi over 180. Again, they both end in 0, so I can cancel those out. Now I have 20 divided by 18. Well, 20 divided by 18, I can take out a 2, which is going to be 10 pi over 9. So what that means is 10 pi over 9 and 200 degrees are equivalent angle measurements, just in different units of measurement. Okay. So now let's look at radians. This is a radian measurement. How do you tell the difference between radians and degrees? This one right here has a degree sign. This one doesn't have a degree sign, which means this is a radian measurement. So that means I'm going to multiply by a fraction. I want to get rid of radians, so that means I'm going to put my radian unit of measurement in the denominator so the unit goes away. That means I'm going to put pi in the bottom and 180 degrees on the top. What that does is it gets rid of my unit of measurement, radians, and radians cancel out. So what happens is now I go through and I reduce. This pi here can cancel out. 180 divided by 3 is really 60. So this becomes 2 times 60 degrees, which is the equivalent to 120 degrees. So what that means is 2 pi over 3 radians is equivalent to 120 degrees. Most of you feel comfortable with 120 degrees. If I told you to draw a 120 degree angle, you could draw it. If I told you to draw 2 pi over 3, you probably wouldn't have a clue how to do that. You will, okay? Just not yet, okay? So let's look at the next one. 7 pi over 4. I want to multiply, and I want to put radians on the bottom, which means I have to put pi down here, and I put 180 degrees up top. Reduce. That goes, the pi's go away. I could multiply 7 times 180. I don't want to do that because I don't know what that is without a calculator. I could figure it out. But what I'm going to do is I'm going to divide the 180 and 4. Both of these have a factor of 2 at least. They actually both have a factor of 4, but a lot of people don't know that. So what do? I take a 2 out of each one. So this becomes 2, and this becomes 90. Well, again, these are both even, so I can take a 2 out of this, and a 2 out of this, and this becomes 45. Now, 7 times 45, well, if you take 7 times 45, you're going to get 315 degrees. Now, if you don't know that, use a calculator. Okay, it's not horrible. Just type it in the calculator and see what happens. Okay. Now let's do the last one here. Multiply by, again, it's a radian measurement, no degree measurement, so this is radian. And I would put radians in the bottom. And my computer's not catching up for some reason. And 180 in the top. So it looks something like this. Now reduce. 8 and 180. Well, they both have a factor of 4 because I did that up top. This would be 45, and this would be 2. Now, 45 and 2 don't have anything in common. The pi's go away, so this would be negative 45 divided by 2. Well, negative 45 divided by 2, you could convert that into negative 24, or or no, negative 22.5 degrees. And that would be your answer. Okay, that's converting radians to degrees. Okay. So now we're going to look at some special right triangles. So I have, basically what we're trying to do is we're trying to find all the side lengths that we don't know. So if this is 8, this is x, this is y. Okay, this is x, this is y. This is x, this is y. We're just trying to find the missing sides. Okay, so now what we do is we go through and we look at this. So I have a 60-degree angle here. I have a 30-degree angle here because all three angles of a triangle have to add up to 180. So here's what I do. I draw my 30, 60, 90 triangle that I know. This is 60. This is 30. So then I need to know what my side lengths are. Okay? So here's the easiest way to do it. 1, okay, is always the shortest side on the 30, 60, 90 triangle. 60 degrees, it's the shortest side. The other side length is going to be the square root of 3. The square root of 3 is bigger than 1. The square root of 3 is about 1.4, I believe. It might be 1. It's actually 1.7, I believe. And then I have 2. So what I'm going to do is I'm just going to set up a proportion from geometry. I have, if I want to solve for x, okay, what I do is I set up x over 8 equals 1 over 2. 1 corresponds with x, 2 corresponds with 8. Set up the proportion, cross multiply and solve. 2x equals 8, x equals 4. So this side length right here is 4. Then do the same process in order to find y. Well, I have y over 8 equals the square root of 3 over 8. Cross multiply, or excuse me, not 8, 2. Okay, again, cross multiply. So I get 2y equals 8 square root of 3. Divide by 2, and you get y equals square root of, or 4 square root of 3. And that would be your x and y. And it's just setting up proportions like you would have in geometry. Okay. Let's go over here and try this one, 16. So it's 45, 45, 90. Okay. So what I do is I draw the 45, 45, 90 triangle. Okay. So this is a 45-degree angle. This is 1. And then this side length over here is 1. And then this one is the square root of 2. And that's just memorizing those side lengths. Okay. That's all there is to it, is memorizing the two triangles. So now we set up proportions. We have x over 16. So I have x, because I'm solving for this one, over 16, corresponds to 1 over the square root of 2. Cross multiply and solve. X square root of 2 equals 16. Divide by square root of 2. And then you get x equals 16 divided by square root of 2. But then you need to rationalize that, which is going to become 16 square root of 2 divided by 2. And then reduce the 16 and 2. And you would get x equals 8 square root of 2. Okay? And x equals 8 square root of 2. Well, guess what? This is 1, so is this. So guess what y is? 8 square root of 2 as well.